हरि करना।
Let's begin with normal or Gaussian distribution. So the normal distribution, also known as the Gaussian distribution, is a continuous probability distribution. It's a continuous probability distribution that is widely used in statistics and the probability theory. So it's characterized by its bell-shaped curve, which is symmetric and centered around the mean. So bell shaped, basically normal curve or normal distribution we have discussed in detail with recreation of the normal distribution curve in other course. The course name is Intuitive Sampling and Distribution for You course. In that we have done everything. I would urge you to watch the if you want to learn in detail about the normal distribution, you watch that video. Or if you just want to know the properties of normal distribution with respect to the random variable, this is the right place for you. Okay, so normal distribution curve is a bell-shaped distribution with tendency with tendency for individual to clump around the group median or mean. So it will have the tendency for individual to clump around the group median or mean. So used to model many biological phenomena, natural phenomena, financial phenomena, and economical phenomena, ecological phenomena. So many estimators have approximate normal sampling distributions. So of course, for the when it comes to normal sampling distribution, then the central limit theorem also comes into the picture. So anyhow, the notation. So y, it's like mu and sigma square is your standard. It's a variance where mu is mean and sigma square is your variance. So f of y is equals to 1 divided by square root of 2 pi sigma square and multiplied by e power 1 by 2 y minus mu all square divided by sigma square. This is what the notation for the normal or Gaussian distribution. And what's the y value? What are the limits for y value? It's in between minus infinity to plus infinite. Same for the mu, minus infinite to plus infinite. Whereas the standard deviation should always be greater than 0. So now here, if you want to obtain this probabilities in Excel, I've just put it here. So we can use a function called norm.dist, and you can mention the respective values, y value, mu values, standard deviation value, and just give one, and you should be able to create it. If you want to do it, you just do it with this one. So virtually all statistics textbooks give the CDF or upper tail probabilities for standard normal random variables. This is called standardized normal random variable where z is equals to y minus mu divided by sigma. So, and this is what a normal distribution density function, PDF, probability density function. And you can see that if between, no, this is the curve. You see that this is in between as this n 100 to 400, and then 75 to 400 based on the size of it. The density, the variability is increasing. Okay. So if you want to just quickly see the properties of the normal distribution include the total, any curve, you just take any curve out of it, the total curve, the total area under the curve is equal to 1 since it represents the probability of all possible outcomes. The mean, the median, and mode are all equal and located at the center of the distribution. The standard deviation controls the width of the curve. The standard deviation controls the width of the curve. The larger the standard deviation, the wider the curve. About 68% of the area under the curve falls within one standard deviation of the mean, and about 95% of falls within two standard deviations. So the normal distribution has many applications in fields such as finance, physics, and engineering. It's often used to model random variables that are approximately normally distributed, such as IQ scores, heights, and weights. Additionally, many statistical tests and methods such as the t-test and ANOVA assume that the data are normally distributed. So this is what one G-score table. So from this you can take the values of the G-score. Okay, and these are the values of these are the second decimal. Here you have 0 0.1, and this you have second decimal of second decimal place of Z. So 0 0.1, this value is 0 0.1, this value is 0 0.01, this value is 0 0.02, this value is 0.90, 0.93, this one is 0.93, this one is 0.11, 0.22, 0.42. Okay, so that's how you get the value. You will have your respective Z value, and you will get the probability from this table. So this is integer part in first decimal place of Z, and this is second decimal place of Z. So first decimal place 0 0.1, this is 0 0.01. So if I select randomly any cell, so the first decimal place is 0 0.6, and the second decimal place is 0 0.04, hence it will become 0 0.64. So when the G score is 0 0.64, then what's the probability? 0 0.2611. When your G score is 2.98, 2.98, and what's your probability? 0.0014. And when your G score is 1.5, 0.0668, that's your probability. When your G score is 2.07, 2.07, then your probability would be 2.07. It's 0.0192. So that's how we calculate the probability of respective G score.